Hi, this is a video on graphing linear equations. We have done it in several ways so far, and I just want to go over those ways so we get a big picture overview. There will be a few other ways we're going to be graphing linear equations in the days to come also. But let's start by some of these ways that we have gone through. So the ways are by a table. So we know we do a table and usually pick about 4 values of x and see what y is. We can do it, put it in Slope-Intercept form, and so we've done that recently. We can put it in standard form, and we looked at how we can know the slope in Y-intercept from standard form. We can find the X and Y intercepts, graph those, and just draw a line through them. And then we've talked a little bit about vertical and horizontal lines. So let me begin with a table, which is in some ways the easiest conceptual way to do it, but it takes a bit of time. But here, let me get out this graph paper here. And I'm going to pick something. I will put it, it'll be solved for y already. So I'll have something like, let's say, y is equal to 2x plus 3. And so to do this, by the way, if it isn't solved for y, it's usually much easier to go ahead and solve for y, but this is already solved for y. So I usually do a bunch of columns like this, and I put x, which is going to be my input value. I'm going to zoom in a little bit here so you can see this better. I'm going to put x, which is my input value. I then put 2x plus 3, because that's what we're going to do with x, to find our output value y, and then we're going to have a ordered pair xy, which is this column and this column. And some people leave that out, but I like to have that in there. So let's pick 0. 0 is always an easy one. So 2 times 0 plus 3 is equal to 3. And we get an ordered pair 0, 3. Another point we can use is we can use 1. So we have 2 times 1 plus 3 that's 2 plus 3 is 5. And so we have 1, 5. Let's try a negative 1. A negative 1, so 2 times negative 1 plus 3. So that's negative 2 plus 3. That's 1. So negative 1, 1. And let's try negative 2. 2 times negative 2 is negative 4 plus 3 would be a negative 1. And I would have the ordered pair negative 2, negative 1. So those are my ordered pairs. I'm going to graph them up here, so I'm just going to go ahead and graph those. So I have 0, 3, 0, 1, 2, 3. I have 1, 5, so 1, and then 1, 2, 3, 4, 5 on the y-axis. And then I have negative 1, 1. And those are lining up as they should. And then I have negative 2, negative 1 right there. It looks like all those should be in line. I'm going to get a straight edge here. And so I'm going to take this, I'll put it here. I'm going to take this, I'm going to put it through here, and I'm going to draw a line. And that's my line, which is y is equal to 2x plus 3. And trust me, that's a y. Okay? And so that's the table method. Okay, let's do the same one with the, so let me label that. So that's table. Over here, I'm going to do the slope-intercept. In the background on the slope-intercept is that we know that if we have an equation in the form of y is equal to mx plus b, the number before the x is the slope, and this other number, the plus number here, is the y-intercept. And that's simply where it crosses the y-axis. And we've talked a lot about slope and so forth. I won't talk about that again here in any detail, but I'm going to use the same equation that we used for the table. So I go y is equal to 2x plus 3. And so I have this, y is equal to 2x plus 3. And what I'm going to do is I know this is the slope, this is the y-intercept. So I'm going to go up to the y-intercept, which is 3, and then I'm going to use my slope information, which is 2, so that's like 2 over 1, right? 2 over 1. Or I could go down to a negative 2 over a negative 1, would still give me a slope of 2, so that could be another point there, but this would be the easiest one, up 2 over 1. And then I'm going to draw a line through that. And voila, I have that. And I'll show you, I'll zoom out a little bit here and show you both of those. So there's the table method, and there's the y-intercept method. And those both, of course, lead to the same result because they were just the same line done in different ways. Okay, the next method is I'm going to use the standard form method. And I am going to use, I'm actually figuring out this here. So I am going to use the standard form method, and first of all, let's review a little bit about standard form. So I'm going to get a sheet of paper here. And standard form is this. It's in the form of ax plus by, so this is some number times x, some number times y, is equal to c. Your book says these need to be any real number. Some books say these need to be integers, and this is not equal to, this is not negative. A and B both can't be negative, or both can't be 0. One of them can be 0. So I usually like to keep these integers, and I usually like to keep this as non-negative, the A. I also usually like to keep that as low as possible while keeping them all integers, but that's usually not viewed as a requirement. And so actually there may be more than one version of the standard form. But here is an equation in standard form. So if I have 2x minus y, that's like plus a negative 1y, so minus y is in the proper form because it's like plus a negative 1y, is equal to negative 3. Okay? So that's in standard form. Now, before we go to that specific one, though, I'm going to go back to the standard form here, which I actually meant to do at first. And I'm going to put this in slope-intercept form. Okay? And I'm going to put this general equation here in slope-intercept form. So I'm going to subtract ax from both sides. And I get by is equal to negative ax plus c. I could go c minus ax, but I could use this as, addition and commutative property, so I could do that, and that's perfectly fine. I can divide both sides by b. Whoa, I need to look at the paper, not the screen. By b, and I get y is equal to this needs to be distributed here over division. So this is the opposite of A over B x plus C over B. So this general form of the standard equation, or the standard form of the linear equation, is put in slope-intercept form, and hey, that means that whenever we have it in standard form, the negative A over B, or opposite of A over B, is going to be the slope, and C over B is going to be the Y-intercept. Okay? Well, like I said before, here I have an equation in standard form. So, and I'm going to put this as plus a negative 1 here just to make it clear. And I want to erase that, but I don't have any eraser. But that's plus a negative 1, trust me. So plus a negative 1y is equal to 3. Well, this is 2 is A, negative 1 is B, and negative 3 is C, right? So we know the slope is going to be the opposite of A, which is 2, over B, which is negative 1, or that's equal to 2. So the slope is going to be 2. The Y-intercept, I'm abbreviating that, is going to equal to C over B, which is going to be negative 3 over negative 1, which is simply equal to 3. So we have a slope of 2 and a Y-intercept of 3. Okay? We're going to use that information now to graph this. And you may have noticed that actually this is the same equation I had before, but I had simply put it in standard form. So we're going to go ahead and graph it now. I'm going to slide up this paper here. I'll probably zoom out a little bit so you can see a little bit more here. But I may not have all of that up there. So we have all of this. And so I know my slope, no, my Y-intercept is 3. And my slope is 2. So I go up 2 over 1. Or I could go down 2 over 1, over to the left one. So this would be negative 2 over negative 1, which is still equal to 2. Or up 2, positive 2 over positive 1 here to the right. And I get a line again. And that was through using standard form, and what we know about standard form, that when we have in the form of ax plus by is equal to c, we know that the slope is going to be the opposite of a over c, I'm sorry, the opposite of a over b. The opposite of a over b is the slope, and the y-intercept is going to be c over b. Okay? So that's our third method, the standard form method. Now, I'm going to do the fourth method, which is called the X and Y intercepts. So what I'm going to do here is I'm going to take the same equation. I think I will use just this graph again. For our original equation, I'll take it in slope-intercept form. It doesn't really matter here. As a matter of fact, I think I'll work down here. I'm going to go y is equal to 2x plus 3. Well, before we get to this, let's go down over here and just think about something. And that is, when I have a y-intercept, what is the value of x? So, like in the one we're dealing with, the y-intercept is 3. So it crosses the y-axis at 3. Well, the value of x there is 0. So this point is 0, 3. Okay, so I can say at the y-intercept, the value of x is 0. Well, similarly, if I pick an x-intercept, so let's say I have this line, which is a different line than we've been dealing with, but let's say I have this line here, and I'm going to draw it. Let's just say I have this line here, and this goes through the x-intercept, x-axis here at 4. So this point, the coordinates of this point are 4, 0, right? The x value is 4, and the y value is 0. And that will be true for any x-intercept. So at the x-intercept, the value of y is 0. Okay, now we're going to, oops, I couldn't see that there, but I left that out. So now we're going to use that information to go back to this equation here. So we got to remember that at the y-intercept, the value of x is 0. Okay, 0. And at the x-intercept, the value of y is 0. So back to this, and we're going to use it here. And so to find the y-intercept, I'm going to set x to 0. So again, to find the y-intercept, set x to 0. So if I go y is equal to 2 times 0 plus 3, I get y is equal to 3, and that is my x-intercept. I'm sorry, that is my y-intercept. Okay, so I'm going to zoom in on that a little bit. And I'm going to correct myself just to make sure everybody is aware of that. When I set x to 0, I end up getting y is equal to 3, and y is equal to 3 is my y-intercept. Now to find my x-intercept, I'm going to set y to 0. So I get 0 is equal to, because that's what y is there, 2x plus 3. Or I need to solve this, and so I get, I'm going to subtract 3 from both sides, and I get negative 3 is equal to 2x. I divide both sides by 2, and I get x, I'm reversing here, is equal to negative 3 halves, or if I want to do it as a mixed number, negative 1 and 1/2. Okay? So, well, I have 2 points here, right? I have this, and I have what x is here. I'm going to go up to this graph. I've already done where it crosses the y-axis. Now this is where it crosses the x-axis. Well, here's negative 1. Here's negative 2. Negative 1.5 is going to be right about there. And now I'm going to draw a line through those 2 points. And I told you it was the same equation as the one we have before. Let me zoom out here a little bit, and you can see that. That's over here is the one that we did with standard form, and this is the one that we did with the finding the x and the y-intercepts. Now notice that when we had the x and y-intercepts, we could have had this if it was in standard form, which was this for this equation. We could have done the same thing. To find the y-intercept, we set x to 0, and we would have still got y is equal to 3. And to find the x-intercept, we would have set y to 0, and we still would have got, as the x-intercept, x is equal to negative 3/2. Okay? Now, there's just one more thing I want to talk about, and that is where we have an equation where it will be something like this. If I have an equation in the form of something like x is equal to 3, and that's it. That's actually in standard form because it's in the form of ax plus by is equal to c, but we have no y there. And we remember that both a and b can't be, both of them can't be 0, but one of them could be 0. So here we just have x is equal to 3. Well, the easy way to graph this is think, where is x always 3? Well, x is always 3 is 1, 2, 3. That point is 0, or 3, 0, right? X is 3 there. This point here is 3, 1. X is 3 there. This is 3, 2, right? X is 3 there. 3, 3. X is 3 there. 3, negative 2. X is 3 there. So what x is equal to 3 is a vertical line running through where x is 3. So you might think, well, vertical line, you might think the y-axis. Well, no, it's x is equal to 3 is a vertical line going here, okay? So x is equal to 3 is a vertical line. If x is equal to negative 5, I would go 1, 2, 3, 4, 1, 2, 3, 4, 5, and put a vertical line through here, okay? So that would be x is equal to negative 5, for example, okay? Now, let's take another example and look at something where we just have a y value. So let's say I have y is equal to negative 2. Well, let's think about where that occurs. Here's the point 0, negative 2. There, y is equal to negative 2. Here's the point 1, negative 2. Here's the point 2, 3, 4, 5, 6, 7. This is 7, negative 2. This is the point negative 3, negative 2. So all along this horizontal line is where y is equal to negative 2. So that's y is equal to negative 2. So, to summarize, we have gone through several ways here to graph lines so far. You remember the table and the slope-intercept, y is equal to mx plus b. And so if you look back at where we went, we got these two things, and we did y is equal to 2x plus 3 there using a table. We saw we could do it much faster with the slope and y-intercept. We find the y-intercept and then just use our slope information to do the second point. We found that in standard form, standard form means ax plus by is equal to c. But we figured out that when we do that, the slope is the opposite of a over b, and the y-intercept is c over b. And so we could use that same information just like we did and to find the graph of the line. We could do it by x and y intercepts because where x is equal to 0, where we set x to equal to 0, we find the y-intercept. And when we set y to 0, we find the x-intercept. We just put those two intercepts down and we draw a line through them. And then we learned about vertical and horizontal lines, that where an equation like x is equal to 3 is a vertical line that goes through x is equal to 3. A horizontal line, y is equal to some number, is a horizontal line that goes through that number for y. Okay, so with that, I will go ahead and end this video.